spinning things are? I mean, really think about it. You've got a force pull. You ever stop and think about how weird spinning things are? I mean, really think about it. You've got a force pulling something inward, but the thing itself just keeps going sideways. How on earth does that work? Well, today we're gonna dive in and unlock the secrets of centripetal motion.
All right, so here's the game plan. We're gonna start with a classic puzzle, then we'll build the answer from scratch. After that, we'll meet the real force behind it all, bust a super common myth, you've definitely heard this one, and then we'll circle back to see how it all makes sense.
Okay, let's kick things off with a puzzle. And this isn't just any puzzle. It's one that's had brilliant minds scratching their heads for centuries. And it all boils down to one simple question.
So think about this for a second. The Earth is pulling the moon straight in with gravity, right? In our world, if you pull on a rope, the thing at the end comes towards you. But the moon, it doesn't. It just keeps zipping along sideways, always at a right angle to that pole. It just doesn't seem to make sense, does it? It's a real head scratcher.
Okay, to figure this out, we're not going to throw a bunch of complicated equations at you. Nope. Instead, let's just build this whole idea from the ground up with a really simple thought experiment.
Picture this. A ball is just rolling along in a perfectly straight line. Got it? Now, what if we come in and give it a quick little tap, but not from the front or back, from the side, perfectly perpendicular? What happens? Well, its path changes. It deflects. Now let's say it's moving in this new direction, and we tap it again. From the side, always at that perfect right angle to its motion. It deflects again. So what if we keep doing this? Tap, tap, tap. But we make the taps smaller and closer together and faster, until it's not a series of taps anymore, but one constant gentle push always aimed at the side. What do you get? You get a perfect circle. That's the secret. A continuous sideways force doesn't pull the object in, it just keeps bending its path.
And just like that, we've basically built circular motion from scratch. Now, that constant inward pulling force that we just discovered, yeah, it has a name.
It's called the centripetal force, and the name is a huge clue. It literally means center seeking. This is the force that's doing all the work, constantly wrestling the object's straight line path and bending it into that perfect curve.
Okay, but here's a super important point, maybe the most crucial thing to get right. Centripetal force isn't some new magical force of nature like gravity or electromagnetism. You can't just go out and find a bottle of centripetal force. A much better way to think about it is, well, it's a job description. It's a role that other everyday forces can take on.
And this whole job title idea clicks when you look at some real-world examples. Let's go back to the moon orbiting the Earth. Who's doing this centripetal force job there? It's gravity. Gravity is providing that constant inward pull. What about when you swing a ball on a string? In that case, the tension in the string is doing the job. And if you put a block on a spinning record player, it's good old friction that's holding on and providing that inward force. See? Different forces, all playing the same role.
All right, I know what you're probably thinking right now. Hold on a minute. You're telling me the force is pulling in, but every time I'm on a merry-go-round, I feel like I'm being thrown out? And you're right, it absolutely feels that way. This is where things get really interesting.
I mean, that feeling is so strong, isn't it? When a car takes a turn too fast, you're slammed against the door. It feels like there has to be some kind of outward force, maybe a centrifugal force, right? Something that's actively trying to fling you out.
Well, I hate to break it to you, but scientifically speaking, there isn't. There is no real centrifugal force pushing you out. It's a myth. What you're feeling is what physicists call a pseudo-force or a fictitious force. It's basically an illusion created by your body's own inertia. Remember inertia? It's just that stubborn tendency for things to keep going in a straight line unless a force acts on them.
So let's put these two side by side. Centripetal force, that's the real deal. It pulls you inward, and it's caused by real things, like gravity or a car door. The centrifugal force, that's just a feeling. It feels like an outward push, but it's really just caused by your inertia. Let's go back to that car turning. The car turns, but your body wants to keep going straight. The only reason you turn with the car is because the door pushes inward on you. That inward push is the centripetal force. Your brain just misinterprets that inward push on you as you being thrown outward against the door. Okay, so now that we know this secret, that the real force is in and the outward feeling is just inertia, let's go back and look at a couple of classic examples and see what's really going on.
First up, that spinning ball on a string. You know the one. As you start to spin it faster and faster, the ball doesn't stay tucked in. It swings out wider. It really, really looks like it's being flung to the outside. But it's not.
So that rope is actually doing two things at once. Part of its pulling power, the up and down part, is just fighting gravity and keeping the ball from falling. Simple enough. But the other part, the side-to-side component, that's the star of the show. That horizontal pull is the real centripetal force that's yanking the ball into a circle. And here is the aha moment. If you want that ball to spin faster, you need a stronger inward pull. You need more centripetal force. But how do you get more of that side-to-side pull from the rope? Well, the only way is for the angle of the rope to get wider. So the ball has to move outward, not because it's being pushed out, but because it needs to get to that wider angle to get the stronger inward pull required to go that